Ừ. there are only 8 students attend the online class. Let's wait for a minute. Okay. Okay, class begins. Last time we have learned about the network protocol and architecture, and we have learned the relationship between a service and a protocol. What about the relationship between a service and a protocol? Then from this figure, we can understand that service means the layer key provide the service to layer key plus 1. Protocol means a peer layer key and the peer and layer key on the other machine. They all obey the same agreement, the same rule on how to communicate with each other. Then we will study the reference model. We will discuss 2 important network architectures, the OSI reference model and the TCP/IP reference model. These 2 models are very famous network architecture. Although the protocols associated with the OSI model are not used anymore, the model itself is actually quite general and still valid. And the features discussed at each layer are still very important. Okay, I'll copy the attendance sent to the WeChat. Okay, TCP/IP model has the opposite properties. The model itself is not of much use, but the protocols are widely used. For example, nowadays the internet is widely used based on just the TCP/IP model. Then the OSI reference model is based on a proposal developed by the International Standards Organization as a first step toward the international standardization of the protocols used in the various layers. It was revised in 1995. The model is called the ISO OSI reference model. Here, OSI means Open Systems Interconnection. OSI reference model, we mentioned just now, is designed by ISO, developed by the ISO, okay? So we call it ISO OSI. It deals with connecting open systems, the systems that are open for communication with other systems. Here, what's the meaning of open systems? Open systems, that means the systems can be connected to other systems and they can exchange information. They can communicate with other systems. The OSI model has 7 layers. Then we will explain what each layers deals with. What's the function of each layer? The OSI model minus the physical medium. So the physical medium is not shown in this figure. So minus the physical medium. The model is shown in figure 20. From the bottom to the top, they are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer individually. It denoted by layer 1, layer 2, etc. The principles that were applied to arrive at the 7 layers can be briefly summarized as follows. The principles is very important for design the reference model, listed as follows. Point 1, a layer should be created where a different abstraction is needed. A layer should be created where a different abstraction is needed. So if it is not needed, then a new layer should not be created, right? So the point one, a layer should be created where a different abstraction is needed. We remember last time we have learned a 3-layer philosopher, translator, and the secretary. Here, there are 3 layers. Each layer has its abstraction, right? Completely different person, philosopher, translator, and secretary of 3 layers. So the point we get the point one of principles. Point two, each layer should perform a well-defined function. So the function of each layer should be well-defined. Point three, the function of each layer should be chosen with an eye toward what? Defining internationally standardized protocols. The function of each layer should be defined according to internationally standardized protocols. Point four, the layer boundaries should be chosen to minimize the information flow across the interfaces. Why this point? The minimizing the information flow across the interfaces, that will make it easy, make it very simple, make the interface very simple. So the layer boundaries should be chosen to minimize the information flow across the interface. Okay. If there is a problem in your system, you can log in the Tencent online class again. Then the time can be calculated. Calculated totally. Okay. Then the system will get the correct time totally. So if there is something wrong in your system, you can log in the online class again. The last point is the number of layers should be large enough that distinct functions need not be thrown together in the same layer out of necessity, and small enough that the architecture does not become unwieldy. Why? The number of layers should be large enough then the distinct function need not be thrown together in the same layer. It will make each layer very clear. The function, the distinct function of each layer is very easy and clear to implement, right? Then the number of layers should be small enough. Then small enough, then the architecture will not be fat. It does not become unwieldy, right? It will be very efficient if the number of layers is small enough. Then the architecture and the system will be efficient. So here says does not become unwieldy. So the principles were applied at the design of the 7 layers, summarized as the 5 points. It is very important for the OSI reference model or any other system design. OSI model itself is not a network architecture. It's not a network architecture. It is just a reference model, right? Reference model is not a network architecture. Exactly. Why? Because it does not specify the exact services and protocols used in each layer. It just tells what each layer should do, what each layer should do. However, ISO has also produced the standards for all the layers, although these are not part of the reference model itself. Now, I will begin explain the function, the concept of each layer individually. The physical layer is the lowest one of the OSI reference model. Its underlying is the fundamental layer of the whole system. The physical layer is concerned with transmitting raw bits over a communication channel. What's the raw bits? That means 1010 for the original information. So the physical layer is concerned with transmitting raw bits over a communication channel. The design issues of the physical layer have to do with making sure that when one side sends a 1 bit, when one side sends a 1 bit, not 0 bit, okay, 1 bit, it is received by the other side as a 1 bit, not as a 0 bit. Okay. If one side sends a 0 bit, then it is received by the other side as a 0 bit, not as a 1 bit. So the physical layer should make sure the information received by the other side exactly as the as the sender. Sent, okay? Typical questions here are what electrical signals should be used to represent a 1 and a 0. So here, the question is how to represent a bit 1 and a 0. We should use acute electrical signals to represent the 1 or 0 bit. Here, this is a problem. Question 1 is how to represent a bit. Question 2 is how many nanoseconds a bit lasts. That means a bit unit, the width of each bit. How many nanoseconds? How many nanoseconds a bit lasts? With this question 2, how many nanoseconds a bit lasts? Question 3, whether transmission may proceed simultaneously in both directions or in single directions. So whether the transmission can be in both directions. This is question 3. Question 4, how the initial connection is established. How the initial connection is established, or the connection is needed or not. If the connection is needed, how to establish the initial connection. Question 5, how it is torn down when both sides are finished. So if we need a connection, then the connection is established and communicate with this connection. Then when both sides finished, then how to tear down the connection. This is a problem or questions. Okay. Then the last, then how many pins the network connector has? Network connector means network interface, right? Network interface. How many pins the network connector has? 7 pins or 15 pins or 25 pins. How many pins? And what each pin is used for. That means what's the function of each pin of the network interface or network connector. For example, the network connector of RJ45 widely used in the Ethernet local area network. We use the 8 pins, right? 8 pins. The RJ45 network connector has 8 pins. Each pin has a certain function. So we listed some typical questions in the physical layer. And the function of physical layer is to deal with or make sure that one side sends a certain bit, then it is received by the other side as the same bit. These design issues largely deal with mechanical, electrical, and timing interfaces, as well as the physical transmission medium, which lies below the physical layer. The transmission medium lies below the physical layer. That means here, okay. For example, in the system, we have this protocol stack, right? And on other machines, we have protocol stack. Layer 1, layer 2, 3, 4, 5, 6, 7. And there were definitely physical medium, and they connect using network connector to the physical medium. So on layer 1 lies on the physical medium. So okay. Okay, then how about the data link layer? The main task of the data link layer is to transform a raw transmission facility into a line that appears free of undetected transmission errors. So the data link layer, the main task of data link layer is to transform a raw transmission facility into a line that looks like a correct link, right? Make the physical transmission facility appears free of undetected transmission errors. It does so by masking the real errors, so the network layer does not see them. Does not see what? Does not see the errors. Does not see the errors. So the main task of the data link layer is to transform a raw transmission facility into a line or into a link that appears free of undetected transmission errors. It does so by masking the real errors, so the network layer does not see them. Where is the network layer? Network layer is the upper one of the data link layer. So data link layer provides the transmission service for the network layer, right? It accomplishes this task by having the sender break up the input data into data frames, typically a few hundred or a few thousand bytes. and transmit the frames sequentially by having the sender break up the input data into data frames, typically of 1,000 bytes, and transmit the frames sequentially. If the service is reliable, the service provided by the data link layer can be reliable or unreliable. Then, if the service is reliable, the receiver should confirm correct receipt of each frame by sending back an acknowledgement frame. If the service is not reliable, then the receiver's acknowledgement frame is not needed. Okay, so that is how to implement the reliable service. If the service is reliable, the receiver should acknowledge it to the sender, confirm a correct receipt of each frame by sending back an acknowledgement frame. Here, another issue that arises in the data link layer, most of the higher layers as well, is how to keep a fast transmitter from drowning a slow receiver in data. It is also important for data link layer. If the transmitter is fast, but the receiver is very slow, then the receiver will be drowned by the data from transmitter. How can we do? So we need some traffic regulation, right? We should set some red light and blue light for the transmitter, right? We know green light go, then red light stop, right? So we need some traffic regulation mechanisms for the transmitter. So some traffic regulation mechanism may be needed to let the transmitter know when the receiver can accept more data. If the receiver can accept more data, then you can send. You can begin send. If the receiver cannot accept more data, the transmitter should stop, right? So another issue that arises in the data link there is flow control, right? Is the flow control. This is a flow control, right? This is a flow control. So, or some traffic regulation mechanisms. This is an error control, right? The first one is error control, right? Error control. The second issue is flow control. Broadcast networks have an additional issue in the data link layer. How to control access to the shared channel, in the broadcast network. A special sublayer a special sublayer of the data link layer. For example, the median access control sublayer, which deals with this problem. The median access control, usually we say MAC, median access control sublayer, MAC layer, right? MAC layer, the median. So broadcast network use MAC layer to control access to the shared channel. Shared channel, usually we say what? Bus, right? Bus. Okay. Shared channel. So a special sublayer, MAC sublayer, is needed to deal with this problem. So this is the properties of the data link layer listed here. Okay. Then we will talk about network layer. Network layer controls the operation of the subnet. A key design issue is determining how packets are routed from source to destination. How packets are routed from the source to destination. That is a function of the network layer. So routes can be based on static or dynamic, right? Can be based on static tables, routing table. So in the router, there's a routing table. Routing table can be static or dynamic or adaptive. So if it is based on static tables that are wired into the network and rarely changed, then static routing table can be adopted. Or more often, routing tables can be updated automatically to avoid failed components. So usually dynamic or adaptive routing table is adopted in the routers. So here the routes can be standard as path. The routing table or routers, routing table in routers, right? In router. Router is devices works in the network layer, right? So routes can be based on static tables that are wired into the network and rarely changed, or the routing table can be updated automatically to avoid failed components or failed network links. The addressing used by the second network can be different from that used by the first one. Okay, we know in the internet or in the network system, we have different networks, right? We have different networks. They are connected. They are connected with routers, right? So this is network 1, network 2, network 3, network 4. Then the addressing used by the second one may be different from that used by the first one. So if a packet transmitted from the 1 to the network 2, if the addressing scheme is not the same, then there will be a problem. So the second one may not accept the packet at all because it does not recognize the address, or it will not accept because it is too large, right? Too large means they obey different maximum transmit unit, MTU. MTU means maximum transmission unit, MTU, right? So the addressing may be different. Then the MTU, maximum transmission unit, may be different. If the packet is too large for the second network, then the second network should drop the packet directly. This is the issues lies in network layer. The third question is the protocols may differ and other problems and so on. Okay, so addressing, transmission unit, packet size, right? This is packet size. Packet size, addressing, protocol, here address. So, and so on. So many issues should be dealt with in network layer. It is up to the network layer to overcome all these problems to allow heterogeneous networks to be interconnected. So in the real network system, probably there is many heterogeneous network. That means the networks obey different standardization, obey to different standard. So they are heterogeneous. How to connect this heterogeneous network? Make them interconnected. The network should deal with very well and overcome all these problems. So let's have a rest for 10 minutes. Let's have a rest for 10 minutes. Please keep connection. Please keep connection to the online class. Please keep connection to the online class. Next section, I will check the attendance again. Okay? Okay, let's continue. Okay, let's continue. Please return to the online class. Please return to the online class and make your online class window. Make your online class window active. Okay, make your online class window active, or the length of your studying time is not correct. Okay, because the system only the system recognized your online class window is active, then the attention system will consider that you are active in the learning and not do other things. So only your online class window is active, then the attention system think you are learning. Then your length of the learning time is correct. Okay, please return to the come back to the online class. Okay, in last section, I have explained what's the function or what's some issues of the physical layer, data link layer, and network layer. Then the transport layer. The basic function of the transport layer is to accept data from above it, split it up into smaller units if need be split. Okay, pass this to the network layer and ensure that pieces all arrive correctly at the other end. So this is the basic function of the transport layer. To accept data from above, from the session layer, right? To accept data from above it, from the session layer. Split it up into smaller units because the data from the above layer probably is very large. So it should split up the data block into smaller units if needed. Then pass these units to the network layer, right? The network layer is the neural one of the transport layer, and ensure that the pieces all arrive correctly at the other end. The transport layer also determines what type of service to provide to the session layer, right? And ultimately to the users of the network. The most popular types of transport connection is an error-free point-to-point channel that delivers messages or bytes in the order in which they were sent. So a typical service provided by transport layer is reliable or unreliable. It's reliable, right? So the most popular type of transport connection is an error-free Error-free means the transport layer provides reliable service to the session layer. And the connection is point-to-point. Make the connection looks like a point-to-point channel, physical or logical channel, that delivers messages or bytes in order as before, in the order in which they were sent. That means keep order, right? Keep order. The transport layer is a true end-to-end layer. End-to-end, that means from a certain source to a certain destination. It is a true end-to-end layer. What's the meaning of the true or false? True and end-to-end layer. Because transport layer carries data all the way from the source to the destination. In other words, a program on the source machine carries on a conversation with a similar program on the destination machine, using the message headers and control messages. So that is the basic function of the transport layer, is to provide a transmission service to the session layer. Usually provide reliable transmission service, right? And the transport layer provides an end-to-end transmission service, end-to-end, from the source to the destination. Then the fifth layer called the session layer. The session layer allows users on different machines to establish sessions between them. So the session layer makes the machines can establish sessions between one machine to another machine. Sessions offer various services, including dialogue control, token management, and synchronization to pick up from the synchronization, dialogue control, token management, and the synchronization of the session. Right? Dialogue control probably to keep track of whose turn it is to transmit at a certain time or at a certain time slot. Who can transmit? The others cannot transmit. So to control the dialogue, whose turn it is to transmit. This is the function of the session control. Then token management. Token. What's the token? Token is a command, is a flag. Token is a flag. Means if you have the token, you can transmit. If the others hold the token, then you cannot transmit. So preventing two parties from attempting the same critical operation simultaneously. The critical operation probably to use the channel, transmit its data to the channel. If this is a critical operation, then we can use token control to control them, prevent two parties from attempting the same critical operation simultaneously. The third one is synchronization, means checkpointing long transmission to allow them to pick up from where they left off in the event of a crash and the subsequent recovery. This is the function of synchronization. So session layers is also important to provide service for the application communication. Then the sixth level, the layer 6 is presentation layer. What's the function of presentation layer? It is concerned with the syntax and the thematics of the information transmitted. In order to make it possible for computers with different internal data representations to communicate, the data structures to be exchanged can be defined in an abstract way, along with a standard encoding to be used online on network, right? So in order to make it possible for computers with different internal data representation, that means because the network may be heterogeneous, the computers in the network probably are heterogeneous. They use different representation for internal data. How to communicate? They should use some common format, common representation for the data transmitted, right? So the data structures to be exchanged can be defined in the common abstract way. In the abstract way, that is the common format, along with a standard encoding to be used online. This is what is concerned. The presentation layer manages these abstract data structures and allows higher level data structures to be defined and exchanged. This is a function of the presentation layer. So the under layer is about data transmission, right? The above layer above, is about how to present the data, right? How to control the session, how to present the data transmitted. That is different between the below layer and the above layer. Okay. Layer 7 is application layer. It contains a variety of protocols that are commonly needed by users. One widely used application protocol is HTTP, means Hypertext Transfer Protocol, HTTP, which is the basis for the World Wide Web. It is one of the variety of protocols. There are many application protocols. HTTP is widely used. Is the basis for the World Wide Web application. When a browser wants a web page, it sends the same of the page. It sends the name of the page or the location, the URL of the page. It wants to the server hosting the page using the HTTP. The server then sends the page back. So the World Wide Web application is also a client server model. Is based on CS model or client server model. Right? So other application protocols are used for any other applications, such as file transfer. We use file transfer. We use FTP, file transfer protocol, FTP. File transfer protocol, FTP, and the electronic mail is email, right? Email, we use SMTP, MIME, the port, IMAP. So when we use the email, these protocols evolved. Simple mail transfer protocol, multi-purpose mail extension, multi-purpose internet message extension. So here multi-purpose internet message extension, MIME, POP, post office protocol. So post office means POP, post office protocol, POP. IMAP means internet message access protocol. All these protocols works for email, right? Okay. And other networking news and other, for example, Telnet, right? Telnet, we can log in to the remote machine. Looks like operates the machine face to face. And the DNS, domain name system, means domain name system, domain name. system. We use this application every day. Okay, DNS domain. For example, we type www.njupt.edu.cn. Then, if we type this domain name in the address of the browser, then we can access the home page of our university. So this is a domain. Then this domain name system can map this domain name to the IP address of the World Wide Web server of our university. So this is a domain. Or we can DHCP. DHCP, dynamic host configuration protocol. So this is a protocol widely used because the wireless network is widely used. It can configure our computer automatically. DHCP, etc. Many protocols, many application protocols. Now, we will talk about, just now we have talked about OSI reference model, Open System Interconnection reference model. Now, I would talk about TCP/IP reference model or TCP/IP architecture. It is some different from the OSI reference model. TCP/IP reference model is the reference model used in the ground parent of all wide area computer networks. Ground parent of all wide area computer networks, the ARPANET, and its successor, the World Wide Internet. The ARPANET was a research network sponsored by the DoD, U.S. Department of Defense. From nearly the beginning, the ability to connect multiple networks in the seamless way was one of the major design goals. So, from nearly the beginning, the ability to connect multiple networks in a seamless way. It is just the design goals of ARPANET. This architecture later became known as the TCP/IP reference model after its two primary protocols. What are the two primary protocols? TCP protocol and IP protocol. TCP means Transmission Control Protocol. TCP means Transmission Control Protocol. right? TCP means transmission protocol. IP means internet protocol. These two primary protocol. So the TCP/IP reference model named from these two primary protocol. It was first described by Cerf and Kahn in 1974. Cerf and Kahn are very famous in the internet field. Very famous. And later refined and defined as a standard in the internet community by Brandon in 1989. The design philosophy behind the model is discussed by Clark in 1988. So, Cerf and Kahn designed the TCP and IP protocol, and later refined and defined as a standard by Brandon. Later Clark, Professor Clark, discussed this design philosophy behind the model in 1988. Okay. What's the content of TCP/IP reference model? Then it defines four layers architecture. The lowest layer in the model is the link layer. It describes what links, such as serial lines and classic Ethernet, must do to meet the needs of this connectionless internet layer. It is not really a layer at all in the normal sense of the term, but rather an interface between host and transmission links. Then the internet layer is the link is that holds the whole architecture together. The internet layer's job is to permit hosts to inject packets into any network and have them travel independently to the destination, potentially on a different network. Because in the internet, networks may be heterogeneous. They use it's based on different techniques, right? So they are heterogeneous. They may even arrive in a completely different order than they were sent, in which case it is the job of the higher layers to rearrange them if in-order delivery is desired. So almost the time, usually in-order delivery is desired. We expect the data is delivered in order. So network, but internet layer cannot keep order. They may even arrive in completely different order than they were sent. The internet layer defines an official packet format and protocol. called IP, means Internet Protocol, right? Internet Protocol, plus a companion protocol called ICMP, means Internet Control Message Protocol, that helps it function. So ICMP is an important protocol in the Internet layer, but it is not a core protocol in Internet layer, right? So we know IP is the core protocol of the Internet protocol of the Internet layer, right? IP is the core of the Internet layer. But ICMP is very important, and it is a companion protocol with IP. Do you understand? ICMP is important, although it is not the core of Internet layer, but it is a companion with the core protocol IP that helps it function. The job of the Internet layer is to deliver IP packets where they are supposed to go. Packet routing is clearly a major issue here, as congestion, though IP has not proven effective at avoiding congestion. So packet routing is clearly a major issue here. So the main function or the main job of Internet layer is packet routing using IP and ICMP. What's the function of ICMP? ICMP means to control some arrows of the Internet. If there is some arrows in the Internet, then ICMP will reply a report to the sender. Then the sender can know which protocols, which packets occurred errors. In this figure, we show the properties of TCP/IP corresponding roughly to the OSI network, the OSI reference model, right? We have 3 layers in TCP/IP: link layer, internet layer, transport layer, application layer. But physical layer, session layer, presentation layer does not present in the TCP/IP model, right? So this is the difference between OSI reference model and the TCP/IP reference model. Data link layer of OSI corresponds to the link layer of TCP/IP. Network layer corresponds to internet layer of TCP/IP. Transport corresponds to transport application to application. Then the transport layer of TCP/IP, it is designed to allow peer entities on the source and destination host to carry on a conversation, just as in the OSI transport layer. Two end-to-end transport protocols have been defined here. The first one, TCP, is a reliable connection-oriented protocol that allows a bit stream originating on one machine to be delivered without error on any other machine in the Internet. The second control in this layer, we have UDP, User Datagram Protocol. It is an unreliable connectionless protocol for applications that do not want TCP's sequencing or flow control and wish to provide their own. Usually, UDP is used for real-time. Usually, UDP used for real-time transmission protocol. Used. So real-time transmission protocol, or called RTP, is based on UDP, not TCP. So, for example, on our online class, we need to transmit audio and video streaming, The real-time transmission is, so we use UDP in the transport layer for real-time transmission for audio and video streaming. So the relation of IP, TCP, UDP is shown in Figure 22. Since the model was developed, the IP has been implemented on many other networks. So we listed some typical protocols in each layer. We will illustrate these protocols in later chapters, from physical layer to the application layer. Then the application layer, we will continue to illustrate their properties next time. Okay. Okay, we will stop here. And we'll continue next time. Bye. Okay. Pass over.